Don't touch anything.
All right. Good evening, class. We're back. And what we're going to do now is pick up on the second page, which you would have received tonight. And I just realized that when I had that 5-10 minutes left over in the last class, I got a little ahead of myself. So that round roof, you'll see it tonight, but you didn't have it last week. That was my oversight. I forgot we didn't do that last week. I didn't hand that out. In any case, everything I said was correct. The roof that you can see in front of you there is 56 square feet across. I'm sorry, 56 foot in diameter. All right, that was the book one, and then the one I went over with you was 75 feet. So what I did is I just changed the 75 to an 85 for the problem I'd like you guys to work out. Now, the second part of this problem, which I didn't even get to, was, and I started on it without realizing that was the second part of the number 6, is number 7. All right, now, according to number 7, if you have the same 56-foot diameter roof, round roof, same square footage, 2,463, what size would the horizontal drain be for that? Okay, so let's take a look. So we're going to do 4-inch. We're going to do the 1/4 inch per foot. Right, that tells you right. As soon as you see 1/4 inch, that's horizontal. Right, that would be the horizontal storm drain on page 181. Go to that center column, 1/4 inch, and drop down. You see the first thing that will handle 2643. Okay, and it looks like 4-inch pipe. Just makes it. All right, this one is catching my eye here. That's really close. It's only a few feet below where you have to kick it up to 5-inch pipe, but it still makes it. It's 2650 is 4-inch pipe, and that is the book answer. All right, so it will do 4-inch pipe, 2643 that we need, and what do we have? 2650. All right, so that's what you see written down on this sheet that I gave you. This is my worksheet for these problems. Now, what about the, I'm adding this in. We got the horizontal. What about the vertical? What kind of vertical was there going down to that? On the 2643. Well, let's see. Let's go over to vertical. Vertical was 2643, and 3-inch is, if I said it was big enough on the last one, my mistake. 2643, 3 inches is a little too small. It's only 2200. So you got to go to 4600. All right. So although the book didn't ask for it, it would be 4-inch. So it's 4 down and 4 across. Okay. All right, which takes care of all of number 6 and 7. So that's it on the round roof drains. Okay. The next one is a triangular roof. Okay. Again, I'm sure you've seen about as many triangular roofs as you've seen round roofs, as in they don't exist, except for your license. So what does this look like? Let's do this. Let's go right off of the book. You know what? Let's do an easy one. I'll do a simple one first, and then we'll come back to this. So let's just do a math problem. Okay. Sometimes you'll see this called the base. This is always the base. And this one here is the height. All right. Here it's called the height. I've seen it called altitude. So it means the same thing. Okay. They call it the height. So look on problem number 8. and they give you the formula. They actually do give you the formula here. Base times height divided by 2. So what this means is if this was a square, or in this case a rectangle, triangle is always 1/2 of a rectangle or a square. Okay? So in this case, we're going to write down 25 times 18. Okay, which is, and I don't have this, since I just made it up, I don't have this answer yet. $450. All right, that'd be fine. This here, 18 by 25 is $450. Okay, but we got to divide it by 2 because it's a triangle. And that would be $225. All right, so if this was in inches, which normally our math problems are, it'd be 225 square inches. That's it. So remember that. Now, another triangle, I think this one's a right triangle, looks like this. Okay, this one here, you can see how this is the better example for how the triangle is half. There it is. Okay, it's exactly half. All right, now this one, some of you might remember this from science or math, and you get a triangle like that. You take this and square it, and this and square it, and we'll call this A equals this, and B equals 4, right? So the problem would be, let's get rid of the square. This is C. That's what we're looking for. So we do the C equals A square plus B square. Okay, so let's square them all. I don't know what C is, but I know what A is. A is 3, and B is 4. So this is 9. That's plus, excuse me. 9 plus 16. Okay, so C squared equals 25. Square root of 25 is 5. So this is, I remember this being called a 3, 4, 5 triangle. If this is 3, this is 4, right? Do the math out, and it comes up. This is going to be 5. All right, it's not very hard. I remember when I first saw that in, I think it was in high school. Could have been junior high. I think it was high school. Well, I thought it was, oh, it's a big deal. It's not. I believe they call that Pythagorean theorem. Guy named Pythagoras, I guess, invented it, dreamed it up. But it works. Okay, so if you ever see this leg here, and you don't know what it is, and it's asked on a test, take the other 2 legs and square them and add them together, right? Like this could be 6, that'd be 8, and so on. And this would be, what would that be? 10. Okay? It's easy. All right, so let's get back to the basic triangle. Remember, if you see height, it's the same thing as altitude. All right? Okay, so in this case here, the height is 18. So let's get rid of this. And I'm going to get rid of this too. I've already finished this one. And let's see what they got here. Okay, so they're looking at a roof 72 by 56. Okay. My guess is the 72 would be the bottom one. And the top one would be 56. Now, you want to make it look like a right angle triangle like the one I just had? That's fine. Okay? So this would be a line like imaginary line like that. So how do we do this? We take the 72 times 56, and they tell us that that is going to be 4,000. Where'd it go? 4,032. That's it. Okay, and you got to divide that by 2 to make this a triangle. So this comes out to 2,016 square feet. Okay, we'll call this one a rectangle. This is a triangle. Okay. All right. Now they don't go anywhere with this. They just leave the triangle alone. They just that's as far as they took it. But let's say I asked you to find what kind of vertical roof drain, roof leader this would have. Okay, not mention anything about pitch. So let's see what that would be. 4,032 on the vertical drop. Let's see, divided by 2, it'd be 2,016. That is a 3-inch. All right, so this would be 3-inch. All right, so if the triangular roof was up here, this would be 3-inch. All right, looks awfully small. But then again, this is small too. All right, that's like a house roof. It's pretty small. All right, so what about the horizontal? Let's go over to the 1/4-inch chart, which is the only one we've been working off, until we find something that can handle 2,000 square feet, 2,000 and change. All right, the first one is 4-inch. 3-inch only goes up to 1,160. So we're looking at 4-inch. Again, the book didn't ask for this. I just added it in there. Now, when I give you this assignment, which I'm going to explain right now, I'd like you to add all of these things in, all right? I'd like you to add in, the horizontal and the vertical. All right, let's see what we got. Okay, we're still on that triangular. Again, the triangular was like the last easy one here. The 9 is quite different. All right, so stopping with the triangular roof, it came up to 2,016 square feet. I asked you to continue it on to find out the vertical drop, which was 3-inch, right? And then the horizontal, the 1/4-inch pitch, which was 4-inch. Okay, and we're done with that. All right, now the next one, number 9, is the tricky one. Of all the ones on these 2 pages, it's quite tricky. Let me see what I got for time. I guess we got time. Okay. Now let's say we have a big roof. I'm going to turn this sideways. Maybe I can do it vertical. I guess I can do it vertical. All right. We're going to put one over here. 2, 3, 4. Going to come down. All right. Now, let's do the book problem here that they have. This is the first time that they got tricky and started asking us about these pipes here horizontally rather than everything dumping into this one. Okay, so now we got to find out, could you run a header just like the gas pipe, one end to the other, full size? Of course you could. Nobody's going to complain except your boss, because he only priced it for what was required. We'll say like a 6, an 8, maybe a 10 over here. Okay, so very much like gas pipe. So you're looking for the smallest that meets code. All right. So what's the book looking for here? We got a roof. It's 165 by 120. Okay. And you can read it right off the sheet. I don't have to put it up on here. 165 by 120, multiply it out, comes up to 19,800 square feet. Clearly, this is a very good size, pretty big commercial building. All right. And it has 4 roof drains, which is more like it. It's probably got 4 roof drains scattered around the roof. And they're going to tie together eventually into one. So you take that 19,800 and divide it by 4. Now, I think you can all see this on that paper you have there in front of you. Each pipe is going to handle, is designed to handle up to 4,950 square feet of roof. Okay, so let's go. And they're looking for liters. Liters would be the vertical pipes coming down. You get 4 equal ones coming down. 4950. 4950. All right, so let's go to look at that. 4950 would be what size pipe? All right, 5 inch. All right, and I have it there. Right there, I put down 8650. Now remember what the 8650 is. 8650 is what 5 inch can handle. So it can easily handle 4950. If you drop back to 4 inch on the vertical, 4 inch only goes up to 4600. Right? It's a little bit too small. Not much. A few hundred feet too small. 300 feet too small. No good. Just like gas pipe. It's got to be equal to or more than. So we go from 46 up to 8650, which I have right below where it said liters, and I have a question mark there. You can just cross that question mark right out. That's an old question mark, and I don't remember what that was. It was a long time ago. Okay, so the answer for that one is 5 inch for the liters, the 4 of them. Okay. Now here's what they're asking. Now, so far, it's the same as what we've been doing. It's, not very hard. And what they're looking for is between the 3rd and 4th rain leader. The question I had is, what end are they coming from? I don't know what the heck they're doing. Are they coming left to right or right to left? Well, it only works if they're doing it right to left. Now, I think I drew this out for myself. Yes, I did. On another sheet of paper here. All right, so let's take a peek. So we have 4 5-inch lines. That's a 5. Okay, and each one of them is doing 4950, right? Each one of these 5s is doing 4950. All right, so we got 4950 coming down, going across, and it's joining up with another 4950. Okay, and it's all going this way. And eventually it comes into one big line right here. Obviously, this is going to be the biggest one. Okay, so let's do 4950. What happens? Let's forget about this. What happens when it gets here? Well, let's see. 4950 on the horizontal, again, 1/4 inch scale. That's the only one we're using, excuse me. 1/4 inch scale, 4950. That looks like 6-inch pipe, right? Yep. 4950 is just too big to go into a 5-inch pipe. So we're going to use 6-inch. So this one right here is 6 inch. Okay, now it joins up with this one. Now 4950 and 4950 is, let's do it. So right here, times 2. Okay, 9900. So this pipe right here has to handle these two, which is 9900. Okay, so this one is 4900. This one is 9900. Okay, well, let's look at the chart. Chart says 1/4 inch pitch, 9900, looks like 8 inch pipe. Okay, now let's make that 3 of these here. 3 times 4950. Okay, oops. Okay, you're wondering why is this 8 and this 8? Well, 8 inch covers a lot of ground. Okay, 8 inch goes up to 16,300. Okay, it goes from 7550 up to 16,300. All right, so it had to be 8 here because it falls within the 8 inch range. It's over 70. The next size down from that was what, 7,500. That was 6 inch. Too small. All right, so it had to be 16, which is 8. This one here is under 16. It's getting towards the high end of 16. I mean, the high end of 8, which is 16, but it's still 8. All right, this is the answer they were looking for. So the answer to the book question was, what would the size be between the 3rd and the 4th? Now let's do this. I'm going to put this up at the top. Try a different color. 4, 3, 2, 1. Apparently that's how they're numbering it. If you reverse it, it doesn't make any sense and it doesn't work. This way works. All right, so what they're looking for is between the 3rd, how do they word it? The 3rd and the 4th rain leader. These are leaders, remember. So this is what I'm looking for right here. Right? And you come down and it's 8 inch. Okay? Absolutely make a note of this. We have not done this before, right? All we did was the easy way. We just looked for this one, right? Even if they had a couple of leaders coming down, we just looked for what it all added up to. Now, that was the book question. All right, now the obvious one, we didn't get to it yet, was if we had 4 of these coming down, 4 of those coming down, well, we already have the answer for that. It comes up to 19.8. The book already gave us that because we divided that by 4 to get this, right? So we got 19.8 right here. Question is, what size pipe? Well, let's go back in the chart. All right. 19.8 on the horizontal. Too big for 8 inch. 8 inch only goes to 16. 16.3. Looks like 10 inch. Okay. Okay, the book did not ask for that. They asked for this. So this was the answer to that part of the problem. Glad this worked out. Okay, so numbers all add up. Okay, now we're going to shift gears. We're done with the roofs. Why this problem here is here, I'm not sure. It's kind of like if you made a roof out of a donut. is what they're talking about. So I'm going to get rid of this again, and I'm serious. I know you guys don't ask many questions, but if there's anybody's got a question on this, because this is new, speak up. My guess is if anybody's got a question, I'm sure other guys do too. All right, the last one, 24-inch gasket with a 14-inch hole in it. It's a big donut. So you got a gasket, and you got a hole in it. Didn't work out too good. Like that. Okay, and on the outside, this thing would measure, what was that again? 24. Okay. So what it is, it's a very simple one where you just figure the area of the larger, 24, and then deduct the area of the smaller. Okay, and that's exactly how they do it in the book here. I mean, not in the book, excuse me, in the handout sheet. I think all of you got the hang of this. The trick to this one, if there is a trick, is that you got to deduct the smaller from the larger. All right, so once you figure out the area of a 24-inch circle, which is the first one they did, they come up to 452. Now we're going to take this out of the middle, and that comes up to 153. Okay, you deduct them, and you come up with 299. Very simple. Now, I don't know if any of you guys have ever done gaskets before. What we used to do is if it was like any of you guys that have accounts in old mills or places where they might have some old steam lines, what we would do is take it apart. Sometimes it was a nightmare trying to break those flanges apart, but you get it apart eventually, whether you have to chop the bolts off, and now you got those, you can just zip them right off. But now you got a gasket. You're not going to find, I'm sure you're not going to find that gasket. So you're going to have to make one. And I remember we made gaskets out of different material, rainbow packing, right? You used to buy it by that, it's like red rubber, maybe 1/8 inch thick. You buy it like by the square foot. And if you think of it in class, if anybody's done this, unfortunately, you're not going to see this video until after I already talked to you. But if you think of it, maybe the class after, I'd love to hear a story about making gaskets, what you guys are using these days, right? Like I say, my gasket making days are way back when I was an apprentice, maybe a very early journeyman, so a long time. But that's what we used to do. We'd cut the gasket out, and it would look just like this, for those of you who haven't done it. And you might have, I don't know, 6 or 8 or whatever it is, bolt holes that you'd have to allow for, right? And what you could do is just cut the gasket out, right? Put it in place, because this is a part now. And what you could do is just magic marker or pencil the holes, right? And then cut those out, right? Different ways to do it. You could just leave it in place and punch it through with something, or cut it right in place. Different ways to do it, right? But I think we used to cut this with I don't know if we used tin snips, or I don't think we had a pair of scissors around. But this red rubber was easy enough to cut. Wasn't hard to cut at all. All right, but anyway, they included this with the roofs, right? Okay, here's what I want to do before we wrap this one up. Actually, we're coming up pretty good on the time. What I like to do is this. Let's go back to the top of number 6. And I put some numbers down there. All right, they had 56. What I did is I penned in 85, because if you remember at the end of the last class, I got a little ahead of things. I forgot you didn't have this. And I did 75 for you, right, in class. I did the 56 and the 75, and that's where it ended. So what I did is I just added this one in. Do an 85-foot diameter roof and go through the math, right? You can see the book answer there, how they did it for the 56. You could use that. And while you're at it, see if you can give me the vertical drop for 85-foot roof, the vertical and the horizontal. Okay, so add those in. Number 7, which actually number 7 is exactly what I just asked you to do. All right, so number 6 and 7 are really one problem. Find the area, which is number 6, and then number 7, find the vertical drop and the horizontal. Horizontal would always be equal to or bigger than. Most likely it'll be bigger than. Number 8, a triangular roof. I added in some numbers there. Instead of 72 by 56, which you have, I added in 85 by 72. Okay, do that, and then do a single drain. Okay, single roof drain, vertical, and then a horizontal, always 1/4 inch to the foot. So figure that out also, even though the triangular roof did not ask that, right? They just left it alone. They just walked away from that. Once you got the area, they were gone. All right, so just do one vertical and then one horizontal for for that new problem. Number 9. Okay, another problem is there's a separate one. This was a tricky one with 4 drops, which I already erased. The 4 drops coming down. Okay, change the size of the roof from 165 by 120 to 182 by 133, which is on the sheet. All right, and I'm sorry, there's some writing down where it says liters. The 5-inch equals 860, 8,650 square feet that you have, right, available with 5-inch pipe, but you're only looking for 4950. So be aware where that 8650 came from. That's right off the chart. Okay, now the last problem, and again, go with the between the 3rd and the 4th liter, see what it is. Why don't you try to do the whole thing? Do the 4 drops like I did, and see if you can find the horizontal between 3 and 4, 2 and 3, 1 and 2. Okay? Again, it's very much like sizing gas pipe. Okay, so drop them down as you're getting rid of the roof drains. All right, now the last problem, it's a gasket. Okay, it was 24 by 14. I changed it to 35 by 19. Now, unfortunately, I should have put that below the 24 and 14. I don't want it to get mixed up with the one above, the roof problem. So that 35 and 19, go with the gasket. All right, so don't get mixed up with that. I put down 35 inches and 19 inches. So just solve the same problem that we just did. Just change the numbers around a bit and see what you got for square inches at the end of that problem. Okay, now that is the assignment for tonight. And like I said, I would like you to do those 4 liters coming down, the horizontal between each one. 1 and 2, 2 and 3, 3 and 4. And then, of course, after all 4, what do you have? Just like we did on the smaller roof, the 165 by 120. All right, that will take you a while. All right, so that is it for tonight. I think we're just about out of time, and I will see you guys next week. Okay, see you then.